Do you like to play soccer or watch a hockey game? When a hockey player hits the puck, he exerts a force. The stick hits the puck, causing it to move. When the soccer player kicks the ball, she exerts a force, causing the ball to move. Forces push or pull objects. Forces are exerted when objects come in contact with one another. A basic principle of physics is that an object will not move unless acted upon by a force. Whether a computer on a desk, a bus in a parking lot, or a soccer ball, an object will remain in the same place unless something causes it to move. This principle also applies to moving objects. If the player hits the puck hard enough and the hockey rink was big enough, the puck would continue moving in the same direction forever. If there is no unbalanced force on an object, its motion will not change. Just because an object remains stationary or because an object moves with constant velocity, it does not mean no forces are acting at all. For example, the force of gravity is acting on the 8-ball, keeping it stationary. In this case, the force of gravity is opposed equally by the normal force exerted by the table, which pushes up against the force of gravity. The two forces balance, and so there is zero net force and the ball remains in position on the surface of the table. When the player strikes the white ball, hitting the 8-ball, energy is transferred, so the 8-ball is subject to an unbalanced force. If the net force of an object is zero, then an object at rest will remain at rest. Likewise, an object in motion will maintain its motion, in a straight line at a constant speed. When the puck is at rest, no net force is exerted on it. The puck stays at rest until a net force starts its moving. When the hockey player hits the puck, the stick exerts a force on it. Unlike the stationary puck, the forces no longer cancel out, so the motion of the puck changes. Changes in the puck's speed and direction result from the applied forces. The energy of the swinging hockey stick is transferred to the puck. In this case, the application of force over a distance, the swinging of the stick, performs work. The puck's motion is steady. It glides across the ice so long as no one touches it. Of course, gravity is also acting on the puck, pushing it down on the ice and causing friction between the two surfaces, so the puck will eventually come to a standstill. When forces do not cancel each other out, there is a net force, which causes a change in the motion of an object. The object's motion can change in speed or direction. Some forces can act on objects without touching them. If you jump in the air, an invisible force pulls you to the ground, gravity. Gravity does not touch you, but it still acts on you. Have you used a compass to find direction? If the compass needle is moved, it swings back to point northwards. Earth's magnetic field does not physically touch the compass needle, yet it still causes it to move. When you take clean clothes out of the dryer, they sometimes stick together. Even though some of the clothes may not be touching, they still seem to want to stick together. The electrostatic force arises when objects become charged. Objects of opposite charge attract. When an object is negatively charged, it will be attracted to an object that is positively charged. The most dramatic example of the electrostatic force is lightning. In this case, the force acts between a cloud and the ground, even though neither touches the other.